Hey, yo, 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 yo. Hope everybody's doing well. Thank you for tuning in. Thank you for watching. We're going to talk about graphing non-proportional relationships using the slope and the y-intercept. So we're going to graph these without making a table and without plotting those points from the table. So before, what we have done is we made a table of an equation and then we plotted the points using that table onto a graph. Now we're going to graph just by looking at a slope and looking at a y-intercept when the equation is in slope-intercept form. So let's just get right to it. So for A right here, notes guided practice for A, for this first graph, graph y equals 2/3 x minus 1. So the first thing we need to figure out is what's the slope and what's the y-intercept. Well, the slope is 2/3. It's always a number attached to the x. The y-intercept is always what's going on afterwards. So the y-intercept is -1. We're going to use these two bits of information in order to graph this line onto a coordinate plane. So the y-intercept, definition of the y-intercept is where the line crosses this y-axis. So the y-intercept is -1. So I'm going to find on where y is right here, I'm going to look for -1, which is right here. So we always start from the y-intercept. So once we start from the y-intercept, so here we go, I'm starting right here from the y-intercept. I put a point there. That's one point that's on this line. From here, I'm just going to use my slope. We know slope is rise over run. So that means I'm going to start from this point and I'm going to use my rise and I'm going to use my run. So my rise is 2, my run is 3 because it's rise over run. Rise is 2, run is 3. So I'm going to start at this point and I'm going to count up 1, 2 for my rise. And then I'm going to do my run of 3. 1, 2, 3. There's my next point on the line. I went up 2 over 3. And then I got to do it again from here, from this next point. I got to go up 1, 2 over 1, 2, 3. There's another point. I could go down, but if I go down, I mean I got to go to the left to maintain that positive slope. So I can go down 1, 2 over 1, 2, 3. And this is going to maintain a slope of up 2 over 3, up 2 over 3, up 2 over 3, because that's rise over run. There's my line. I can just draw a line right through it, and I'm done. I started from my y-intercept of -1, then I went up 2 over 3, up 2 over 3. And then one quick check, I just want to make sure I have a positive slope. We know positive slope means it's going uphill from left to right. This is going uphill, so it's positive, so I did it right. So then for B right here, we're always going to start from our y-intercept first. So our y-intercept is +3. So that's going to be 1, 2, +3. Because again, it's always just on that y-axis right here. So the y-intercept is +3. And then from that y-intercept, this is where I want to use my slope. Well, my slope is -5 over 2. So remember, this is the rise, this is the run. So rise over run. But because it's negative, instead of going up for my first point, I'm actually going to go down and to the right. So I'm going to go down 5. 1, 2, 3, 4, 5. But then I'm still going to go to the right. 1, 2. And if we look, this is my next point. So I went down 5 over 2. If I start connecting these points, it's going to go downhill, which means it's going to give me a negative slope. So I went the right direction. Let's do another point. 1, 2, 3, 4, 5, 1, 2. There's my next point right there. And then I cannot draw a straight line between these. Oh, maybe I can. Let's try it with a mouse instead of my pen. Whoa, that was weird. Here. So I'm going to connect these points. I don't know what it's doing, guys. My computer is having a spaz attack. What is happening? Sorry, I don't know what's happening. But That's me trying to draw a straight line with my pen. It wasn't the worst, wasn't the best. I'm done. So it has a slope. It's going downhill. It's a negative slope from left to right. We're going downhill. My rise and my run is 5 over 2. 5 over 2. And that's it. I want you guys to try number 2. Try this one on your own and see how you do. So try this one. See how it goes. So pause the video. Try it. And then just see what happens. So I get y equals 1/2 x plus 1. So hopefully you already have a graph on here, but because I'm always going to start from this y-intercept, so my y-intercept is positive 1, so I'm going to start at positive 1. My slope is 1 over 2. It is positive, so I'm going to go up instead of down. Positive up 1 over 1, 2. So there's my next point. Up 1 over 1, 2. I could have gone down, but I'm going to go to the left to keep the going in the same direction. And I'm done. Okay, so if you didn't try that one, or even if you did, I want everybody to try this one. Now, this one real quick though. The rise is -3, the slope is -3, but that means your run is 1. So remember, whenever it's a whole number, just put a 1 in the denominator. Okay, so pause it, try it, see how you do. So again, I'm going to start from my y-intercept. My y-intercept is positive 4. So I'm going to start here on positive 4. Then I use my slope. Because it's -3 over 1, because it's negative, I'm going to go down and to the right. 1, 2, 3 over 1. 1, 2, 3 over 1. And there's my slope. There's my line. Okay? And that's all we got. Okay, so negative slope, it's going downhill from left to right. Positive slope is going uphill from left to right. We always start from our y-intercept, and then we use our slope from there. So sometimes you'll actually have to create your coordinate plane yourself, and then we'll look at this line to be able to make predictions. So here we have Ken, who has a weekly goal of burning 2,400 calories by taking brisk walks. Here's his equation. Represents the number of calories Ken has left to burn after X hours of walking. So it looks like he's burning 300 calories per hour, and he wants to burn 2,400 calories total. Okay. So, and he burns 300 calories per hour. So this is my equation. So what we're going to do is we're going to graph this, and then we're going to actually look at our graph to see if we can make a prediction. Now, one thing we want to notice about our graph is notice how we're starting at 2,400. That is a lot. So what we can do is we can graph by counting by 200s. We can even count by 300s if we want, count by 100s. But we're going to have to show that on the graph in order to make this accurate. So I'm not going to count by 100s because I would need 24. So I think I'm going to count by 200s. So here's 200, 400, that's 600. Now I'm just going to go skip one, 800, 1,200. 1,600, 18, 22, 26. But then now for my X values, because it's just per hour, I'm going to count by half hours. So it's going to be half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9. There we go. So there's my graph. I started with my Y values and my X values. I know my X values are hours because we know it's $300 per hour, and that means 300 calories per hour right there. So I made my coordinate plane. Now I'm going to start from my y-intercept of this graph. The y-intercept is right here at 2,400. So there's my y-intercept. Now this is where we have to be careful. Okay, the slope is down 300 over 1. Okay, so because our graph, we can't just count right here. I can't count 300, right? But if I look, my graph is counting by 200s. So because the slope is going down 300, and I'm starting here, if I go from here to here, because this graph is counting by 200, this is down 200, and then halfway would be down 300. And that's going to be over 1. Now notice how I skipped over 2. Well, because this is 300, and this is 1 hour. I'm going to do the same thing. So this is going to be down, really we're going down 1.5 each time. 1.5, and then we're going over 2. 1.5 over 2. 1.5 over 2. 1.5 over 2. 1.5. And I'm just going to keep this pattern going. The reason why I'm going over 2 is because my graph, I'm going over 1 hour. So I'm going from 1 to 2, right? I'm going from this one from 1 hour to 2 hour, 2 hour to 3 hour, 3 hour to 4 hours, so on and so forth. And I'm going down 300 each time. All right. I feel like I might have messed up somewhere. No, I didn't. We're good. Okay. Okay. So, I did mess up somewhere. I messed up on my counting on my Y. I'm like, I knew something was wrong. Here's where I messed up, guys. And I apologize. It's not the end of the world. The whole process we did made sense, but I just was a goofball. This was 1,600. This should have been 2,000. And then that means that this one right here was 2,400. I apologize. I messed up all of our graphs. So our graph's a little bit inaccurate right now. Someone's going to fix this. Whoop. Because I started with my y-intercept. I went from 1,600 to 1,800. I skipped it. I messed up. So 2,400. Now I can go down 1.5 over 2. There we go. Apologies. I'm going to pause the video and I'll finish this graph by doing that same pattern we just did. Okay, so here's all the points and what it should look like after I fixed it, after my big mess up there. And then if I were to connect all of this, my line would look something like that. Now, I have my line. Now I can make a prediction. After how many hours of walking will Ken have 600 calories left to burn? This line shows me how many calories he has left to burn after his walk. So I got to find 600. Here's 600. That's after 6 hours. After 6 hours, he's going to have 6 calories left to burn. So I can use this line to then answer certain questions. Okay, big ideas though for this whole thing, okay, is that our rate of change is our slope, okay? And then also what I want to do is for things to remember, right, start with y-intercept. And then use your slope. Start with your y-intercept and then use your slope. Try this independent practice by graphing this and see how you do. The coordinate plane's already been made for you, but be careful with your slope and be careful by what they're graphing by. And that's it, guys. I hope this video helped. If you have any questions, let me know. Radius out.